All right, so looking at number one, we're asked to construct a frequency table and a correctly labeled frequency histogram. So I put my data into the statistics app in my NumWorks. So I'm going to go to graph. I'm going to select histogram. Now that's a lot of bars. I don't know that I want to have that many. Right? So what I'll do is I'll go into settings. Instead of the bin width being 0.5 and starting at 0.6, I'll start it at 0 and go by ones. And that gives me something that's a whole lot more, call it palatable. Right? So my intervals and corresponding frequencies. So 0 to less than 1, 1 to less than 2, and so on. All right, the last one there should be 8 to 9. All right, so 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9. All right, and corresponding frequencies, I got 2, 2, 3, 2. 3, 5, 2. 8 and 3. All right, so on my histogram, I need to go up as high as 8. Instead of 4, 2, a 1, so now I know what 1 looks like, so I backfill everything in. All right, and this is again frequency. The intervals, since I clearly indicated them here, I could just use the benchmarks now. So I need to go out to 9. It's not the nicest number, so I'll just ballpark it. 1, 2, 3, 4, 5, 6, 7, 8, and let me actually bring it in a little bit closer. And it doesn't have to be perfect, just best you can. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are my intervals. All right, you could label it based on what it is specifically. You could say allergy index, or you could just say intervals. All right, so 2, 2, 3, 2. 3, 5, 2. Oops, look at that. Just kind of held it too long. Like Daniel Jones. 3, 5, 2. And then all the way up to 8. And 3. Now I could use the autocorrect feature to make this not look abysmal, but I know that you won't have that for the test, so I'm trying to kind of put myself in student shoes. All right. If you have a bar that you see what I did here, it looks not quite the way it should. You could always just put the numbers in. All right, so 2, 2, 3, 2, 3, 5. Back to 2, 8, and 3. Right, and I'll take into account that you have the correct numbers even if the bar doesn't quite look the way it's supposed to. Right. Now number 2 is asking us to use the same data, but this time box plot. So go into type, select box plot. Just make sure for settings, display outliers is turned off. All right. So here I have my number line. It's going by twos, so I'll do that. 0, 2, 4, 6, 8. Goes a little beyond the 8, so I'm going to pop in the 10 there. And you could put the little minors in here. All right. My first value is 0.6. So the minimum is 0.6. Second value, 3.5. So that's Q1. Then we have the median, 5.6. Q3 is 7.4. And the max is 8.4. All right, so box around the middle 3, just like you see in the numworks. This one is, my handwriting was going off the rails, so this one I will use the autocorrect. All right, and so that's my box plot. All right, we stated the 5-number summary down here, so we're good. Same data set, find the sample mean, median, mode, and so on. So let me go up into stats. Sample mean, we're rounding to 3 significant digits, so X bar, oh, that moved on me. Let me just change the setting real quick. All right, so X bar, that's the symbol for sample mean, 5.263. The median, 5.6. Mode all the way down, 7.9. The range, whoa. That's strange. Range, 7.8. Now the mid-range, that's the average of the max and the min. All right, so 0.6 plus 8.4 divided by 2. All right, so that's conveniently for actual real data. This kind of works out nicely. So it's 9 divided by 2, which is 4.5. All right, sample variance, S squared is the abbreviation for that. 5.942. Then sample standard deviation, S, is 2.438. All right, that's all this question was asking us to do. Empirical rule. In order to use the empirical rule, I need to know the mean and the standard deviation. So 5.263 and the sample standard deviation of 2.438. Same values that I got over here, all right? Referring to the same data set. So we got to be really careful about typing in the data correctly. All right, so I'm going to do X bar plus or minus 1S. So into my calculation app, 5.263 minus 1 times 2.438. So on the low end, 2.825. Make the minus into a plus. So on the high end, 7.701. All right, so now what I need to do is count up all the values that fall in that interval. One thing that you might want to do, so if you go back into the statistics app, you might want to sort the data that's in here. All right, so I'm just going to copy it over here so I don't lose its original distribution. So I'm just going to copy V1 into V2, just so I have it there. And then I'll sort this one just sort it right out. Not big enough, 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 not quite big enough. Now we're big enough. So we have the 2.9. So 2.9, 3.5, so three values, 3.8, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 values out of the 30, I think. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. So 18 out of 30. That's about 60%. All right. Needs to be close to 68, not close enough to 68%. So not a normal distribution. All right. If I did get a number close to 68, then I would move on to 2 standard deviations around the mean, looking for 95%, and then 3 standard deviations for 99.7%. Outliers. So this one's a nice one. All right, so let me go into statistics again. Go to graph. Oops. Box plot. Oh, I have my other data set turned on, so let me just go ahead and turn that off. All right, go into settings. Now display outliers. All right, so we would say that there are no outliers because modified box plot is the same as the ordinary box plot. All right. So nice and easy. If there were outliers, those loose points that show up in the modified box plot, then I would say there are outliers because the modified box plot shows disconnected points, or words to that effect. All right. Who performed better relative to their class? We got Jeremy. And we have Chris. All right, so Jeremy got a 90 with a class average. So the z-score here, 90, but the class average is 85 and a standard deviation of 3.2. Chris got a 96. Class average was 91, standard deviation of 5.1. All right, so this is just rote calculation. 90 minus 85. Oops. Divided by 3.2, so 1.563. And then we have, well, I could just do 5 divided by 5.1. So about 0.980. So who performed better relative to their class? Jeremy had a better z-score. So Jeremy with the score of 1.563. Just be careful. I put this one in there as a choice because if you rounded incorrectly, then you'd select the wrong one. So be very, very careful about that.